Hello, everyone. My name is Sergey, and I'm from Percona. I work as a manager of product management. And today I'm going to talk to you about open source database as a service on Kubernetes. It is an interesting topic, and I'm going to just have a brief intro about that. Then we're gonna dive deeper into the value which DBaas provides and understand why it is important. Then we're gonna talk a bit about why databases and Kubernetes and why someone would want to do that. We're gonna review some use cases. We're gonna dive into the complexity of running databases on Kubernetes. We're gonna talk a bit about the solution, which I believe are the operators for databases because they greatly simplify the way you work with them. And I'm going to cover just briefly do-it-yourself DBaas, like a high-level view on it. And I'm going to show a brief demo of Percona monitoring and management with its DBaas capabilities, which is cool and 100% open source, right? So if we talk about the value of DBaas, DBaas is solving the problem for developers and users to provide the database as fast as possible and without the need to know what is going on at the backstage. And the reason is simple. The idea here is super simple. So I, as a developer, I would love to deliver my code faster. I want to test it, and I need a database for that to test something, to test some assumptions or to test my code to see how it works. And a long time ago, the way it worked is developer went to IT department, asked for a server or for a virtual machine. IT department would provision something with some tooling as well and provide it to the developer. And that might take like an hour or two, or even sometimes days in big organization. And in today's world, it's not working. We want to move faster in the world of agile and quick iterations of development. And that is where DBaas comes from. DBaas just gives the developer and the user and the application the database once needed. And the user doesn't know what's going on behind, and it just gets the endpoint to connect to, and the database just works. What is sometimes missing as well is that DBaas is not only a day one operation where you provide a database and provision it, but it also day two operations like backup, scaling, maintenance, upgrades. It is all handled by DBaas as well. If we talk about why databases on Kubernetes, we're going to see some use cases on the next slide. But in a nutshell, we see that it is a evolutionary, right? It started a long time ago on bare metal servers, huge box with one database, nothing else. Then once we saw, and the businesses saw, that there is a huge issue with underutilized servers, because you run one database or one application on a big server, then VMs appeared, virtual machines. And at first, DBAs and administrators, they were hesitant. They were saying, hey, we're going to have performance issues on our for our database to run them on VMs, bare metal forever, and so on. But nowadays, if we look at that, we see that almost all databases in the cloud are virtual machines. Any RDS, any Google Cloud SQL server is a virtual machine in a nutshell, and everyone is using them. And the same going on right now with containers. Containers are great for stateless workloads, and it is still a lot to evangelize here about data on Kubernetes. And persistent storage is there for a long time on Kubernetes, and running your databases there is aligned with the microservices vision of most of the companies, right? You have microservices now, you run them on Kubernetes. Why don't you run your databases there as well and just have them fit into the same microservices model. And what is also super important, what I love mostly about Kubernetes and the databases there is that it provides portability, and as a result, there is no vendor lock-in, because you can run the same workloads on Kubernetes on bare metal servers in your own data center. We can run it on GKE and Google Cloud, on EKS and Amazon, and it's still the same approach. You can still apply the same manifests and get the same result for your developers, for your users, depending how you run your databases there. And at the same time, we all know about automation that Kubernetes provides, recovery of the pods, rescheduling, and if the database is configured properly, you can leverage these automation capabilities of Kubernetes to provide a resilient service. And for Percona, it is interesting because it is also a user-driven thing. We saw our community users and customers asking, how can we run Percona software, Percona databases on Kubernetes? We're moving there. And with this in mind, let's see some use cases, right? I broke them down into the good, the bad, and the ugly. So the good use case for database on Kubernetes and for DBaas as well is something as a service. So imagine you're building your own DBaas, and Kubernetes is a great choice. I will explain it a bit later. You will see it with your own eyes. Or you have some platform as a service or SaaS application which provisions databases repeatedly. You can rely on your homegrown DBaas on Kubernetes for that, and it is a great use case. Development and testing, obviously, once your developer deploys some application on staging, a developer also needs the database. Where to get this database? Okay, here is my DBaas, which is going to provision the database on Kubernetes in a few seconds. Kubernetes shop, it is another story, and it is also what we see in the community and from some of our customers, that the message is basically, hey, we're moving everything to Kubernetes, we're solving some of the problems with it, and we also want to move our databases to K8s. No questions asked, let's just do it, right? The bad use cases, there are a few. One of them is mainframe, and it is just the logical thing. You do not want to take your petabyte mainframe and move it as is to Kubernetes. It is not aligned with microservices view. You'd better break it down into smaller chunks and somehow structure it on Kubernetes with DBaas. But going just as is, move it to Kubernetes and treat it as a VM, well, I don't believe it's going to work that way. I heard it is good. It is another story when someone reads our blog posts or watches our talks, and then they come to us and say, hey, we saw this, we believe it's good, we want to move. And usually it works good if it is already a Kubernetes shop company. But if it's just, I have everything on Amazon and I want just databases to be moved to Kubernetes, well, it's not a good choice, right? I believe that there should be some coherent or aligned strategy where you move everything to Kubernetes gradually, including databases. Not that you just run databases in Kubernetes and everything else outside. It's just not how it should work, I think. And the ugly. What I mean by the ugly, it's not good, it's not bad, it can be done, but I do not think it should be done, is when you have some kind of a startup, you start with Kubernetes right away, because you heard that it is a good technology again, and you have one application, one database that you want to run on Kubernetes. Well, in my case, if you're a startup, if you're a small company, just run your database on some RDS instance in the cloud, and that would be a good start for an MVP, than just going into the Kubernetes right away. And this graph is from the CNCF survey from the last year. And you see there that one of the biggest challenges in using and deploying containers is the complexity. And it is understandable, because when you deploy one single container like Nginx, you think, okay, it's super simple. But once you get into the details and you start to migrate your big application into container world, into the microservices, into Kubernetes, then you start facing the complexity. Then you need to understand how these all things are interacting together. And with this in mind, let's see how complex databases might be. And I like to think about databases on Kubernetes as a two pieces thing. Piece number one is Kubernetes primitives. It is pods, stateful sets, role-based access control, services, and many more Kubernetes primitives that you need to deploy to have your database cluster up and running. And the second thing is database and its components and its configuration. Because imagine you need to deploy a database. It's not just one pod. It's not a stateless application. You need to interconnect this pod somehow with each other. You need to tell them where the primary is, where the secondary is. You need to tell other components of the database like proxies where to route the traffic, and you need to configure it all. So these two pieces, they come together when you need to deploy your database on Kubernetes, and it looks not an easy task, right? And also you always need to remember the volatile nature of Kubernetes, because your nodes, your containers, they can go away, they can fail all the time, and it is normal in Kubernetes world, but it's not so normal for databases. And you need to ensure that your transactions are lost, that your data is safe, and the data on Kubernetes is a bit more complex than running a stateless application. And another thing that I already mentioned, databases on Kubernetes is not only the database itself, it is proxies. You also need to think about how to apply your monitoring strategy to the database on Kubernetes, because probably you will not be able to use your existing tools to monitor the database. Obviously, do not forget about the storage. In Kubernetes, storage complexity is solved through storage classes and CSI drivers, but it's still complex sometimes, especially if you want to do some very custom setups. And as I mentioned also before, do not forget about day two operations when you run your database on Kubernetes. You need to take backups, you need to do maintenance, and you need to do everything in a way that your data is not lost and your application still can connect the database. And the solution, as I see it, to the problem of complexity of running the databases on Kubernetes, not only databases, but also applications, is the operators. The beauty of operators that they live in the world between primitives and application of databases. And in a nutshell, what is happening there is operator is a piece of code that runs in Kubernetes, and you just talk to Kubernetes API saying, hey, Mr. Kubernetes, I would love to get this database with this size, with this number of volumes, with the backup configuration like that. And then operator just provisions Kubernetes primitives and configures the database and its components the way it should be. So it is DBaas in nature. You just tell it through Kubernetes API, what would you love to get? And as the result, you are getting the service, you are getting the endpoint, and you don't know what is happening behind the scenes. You don't know how the database is provisioned. You don't know which Kubernetes primitives are created. You don't care. What you care about is the endpoint. And that is what you get. And it is repeatable as well. You can deploy hundreds of databases. This is why I was saying that databases on Kubernetes is a good use case for anything as a service, because it is repeatable. You can create hundreds of databases through operators easily. And at the same time, you get the DBaas capabilities of day 2 operations. They are all automated through the operator. You tell the operator, I want to add more nodes to my database. Operator handles it, again, creates the primitives in Kubernetes and configures the database so it is handled. It can take the backup. It can roll out updates and do various maintenance tasks, right? And if we talk about operators, it is good to mention do-it-yourself DBaas, because at Percona, we see it a lot. And different companies, different users, they build their own database as a service with our operators. And usually here on the left, you see user and application. And there are 3 scenarios that we saw. First one is the application goes to some kind of a homegrown API, like provision me a database or take the backup, some API endpoint. This API endpoint goes to either some infra as a code tooling, like Terraform, Ansible, and this tooling triggers the creation of the database on Kubernetes through regular API. Or this API directly goes to Kubernetes and does the rest, right? So it's just providing the manifests to the operator to provision or perform some regular tasks for the database through the operator. And another use case which we saw is that application or user connects directly to Kubernetes API to provision and manage the databases on Kubernetes through the operator. And it usually works in the environments where you have a multi-tenant Kubernetes cluster with namespaces, and you have multiple teams which have access to this namespaces, and they just connect to Kubernetes directly because they're pretty experienced. And it works as well. We saw it, and it's a great way to utilize operators on Kubernetes for databases. And one of the things that I also want to mention today in this talk is we have a good tool, Percona Monitoring and Management. It is a 100% open source monitoring and management tool, which is tailored to simplify DBA tasks. And also we have a tech preview. It is now in tech preview, a database as a service capability. And I'm going to show you the demo right now. So I have a Kubernetes cluster on, I think on GKE. Let me check that. Yes, it is on GKE. So I don't have any pods. I don't have anything. And this is how PMM, Percona Monitoring Management, looks like. It's the main dashboard. It provides great monitoring capabilities, but also we have this DBaas thing here. And what I'm going to do now, I'm going to register a Kubernetes cluster. So I just provide a kubeconfig file to it, and this kubeconfig file has a specific user and role that I'm going to use. And what is happening right away is that our DBaas installs the operators right away. So if I would check now, I would see that there are 2 pods already up and running. So it installed these operators automatically. Right now we have one for MySQL, Percona Extra DB cluster, and one for Mongo. And we're going to add Postgres pretty soon, so stay tuned. And once the cluster is added, what I can do is I can provision a database. And I'm going to click create the database. I'm going to name my database cluster test again. I'm going to choose the Kubernetes cluster of my choice. Let's say I want MySQL database version. I'll stay with default. And in advanced options, I'll choose single node because I want it to come up fast. I want to use small. I can also use custom configuration, which is basically the requests and limits in Kubernetes world, but it works like that. And external access. This is going to create the load balancer on Kubernetes so that I can connect and try it out. So that's it. Let's click create cluster. And what's going to happen now, DBaas is going to connect to my Kubernetes cluster. It's going to refresh now. Is it? Let's see. Yeah, so it automatically refreshed and it's processing, right? It's going to create the cluster name test. Let's see what pods are going to appear. Yeah, one HE proxy pod. Remember, I was telling that DBaas is not only the database, it is also proxies, it is also monitoring and other components. And here we have a HE proxy by default for MySQL cluster, and PXE, which is Percona extra, DB cluster, which is Galera and MySQL together for synchronous replication, and they're getting provisioned. So I'm provisioning one node. Of course, it's not recommended for production, but a good use case. Remember one for development and testing. If you just need to spin up the database and play with it, it's a good use case for sure. And let's see, once the database is going to be provisioned, I will show you what else I can do there. Let's see, watch. Oh, okay. Okay, I guess it's up and running. I also can see the custom resource here. It says ready, and also it provides me the endpoint, which is the, also you can see it here. So this is my database, right? I clicked the button and it provisioned the database on my own Kubernetes cluster. And this is the beauty of it. Instead of having a full lock-in on some Amazon RDS or on Google Cloud, you can install PMM in your local environment, point it out to the Kubernetes cluster of your choice, and provision a database through the UI instead of doing it through CLI or some other tooling or through Kubernetes API. And you can manage all these databases. Right now, it's in tech preview, so we do not provide backup capabilities yet, but they are all available in the operator itself. So it's just a matter of readying them in UI, and they will be there in like a couple of months, I think. And you can connect to this endpoint using root and this password. You will be able to connect to the database and execute your regular tasks. But what I love the most here in PMM is tailored to simplify DBA tasks. It is the monitoring, right? And once you have your database deployed, you already have monitoring set up. You can dig into the graphs, you can look into the usage patterns and so on. Right now, you don't have any data here because the database in you, let's see if we can get something for the last 5 minutes. No, it's not there yet, but the metrics will appear pretty soon once you get some usage. And we have query analytics statistics here and many, many more tools and alerting for your databases. So this is the demo of PMM. And again, the beauty of it is it's open source nature. It can be deployed on any environment, anywhere in your on-prem, in your cloud, and you can connect it to any Kubernetes cluster and just provision the databases in there. For now, we support Mongo, we support MySQL, and later on, we're going to add Postgres. And I believe this is it for today from me. If you have any questions, please let me know. You can also follow me and find me on Twitter, and please drop me an email if there is anything I can help you with regarding Percona products. Thank you for watching. I appreciate your time. Take care.